Welcome to the AI Research Roundup. I am Alex. Today, we're looking at a fascinating paper from the Papers with Code trending list, published May 26, 2025, titled HunyuanVideo-Avatar, High-Fidelity Audio-Driven Human Animation for Multiple Characters. This research presents a new model for creating highly realistic, audio-driven animations of people, even with multiple characters and precise emotional expressions. The system is based on a Multimodal Diffusion Transformer, or MMDIT. This is an AI architecture that's skilled at combining diverse data types, like audio and visuals, and generates video through a progressive refinement process. It also features an Audio Emotion Module, or AEM, for detailed emotion control, and a Face-Aware Audio Adapter, or FAA, for managing multiple speakers in a scene. It's great to see they also released the code for this work. So in the repository, you'll find the inference code and model weights. They've got assets, scripts, and even a Gradio demo, which is essentially a tool that lets you quickly build a user-friendly web interface to interact with the model, plus all the instructions for running the implementation. Alright, so really showcases what HunyuanVideo-Avatar can do using just a character image and audio as input. We see examples of it handling multiple characters in one scene, which is where that face-aware audio adapter really shines. Then, it demonstrates diverse character styles, from realistic people to anime and even Lego figures. And finally, it highlights the emotion control, showing characters expressing happiness, sadness, and anger, all driven by the audio input and managed by the Audio Emotion Module. This gives a good visual overview of the model's key strengths. Okay, so it gave us a great overview of the results. Now, dives deeper into the actual architecture of HunyuanVideo-Avatar. We see the reference image being processed by a 3D encoder, which converts visual data into a model-friendly format. And its features are added to the video latent, that's the video's internal representation. This character image injection is key for consistency. Then, the face-aware audio adapter uses audio features and face masks, ensuring audio only drives the correct face, using spatial cross-attention, a mechanism for targeted data interaction. The Audio Emotion Module similarly injects emotional cues from a reference image. So after seeing the overall system and zooms in on a specific part, the Character Image Injection Module. We mentioned this module helps keep the character looking consistent while still allowing for dynamic movement. This figure compares 3 different approaches for how that reference character image is actually combined with the video information. The paper found that a method they call token plus add, where the image features are directly added to the video's internal representation, worked best for balancing that motion and consistency. Alright, moving on from the Character Image Injection Module in CODS gives us a direct qualitative comparison. This time, it's showing how HunyuanVideo-Avatar, labeled as ours, stacks up against several other existing methods like Echo Mimic, Sonic, and Halo. We see results for 2 different reference characters from the HTDF dataset. The figure displays sequences of generated video frames, allowing us to visually assess things like lip sync accuracy, facial expression naturalness, and overall character consistency across these different approaches. It really helps to see them side by side. Okay, so after showed us those comparisons on the HDTF dataset, now demonstrates HunyuanVideo-Avatar's performance on what the paper calls a wild dataset. This means it's tested on a more varied and less curated set of images and scenarios. We again see examples of diverse character styles, like a cartoon figure, a traditional painting style, even a cat. Then, it shows the model's ability to convey different emotions, specifically sadness and happiness in animated characters. And finally, it highlights the multi-character interactions, with separate audio driving different people in the same scene. So, following up on Look at the Wild dataset continues with that theme, but specifically focuses on full-body animation comparisons. We're again seeing HunyuanVideo-Avatar labeled as ours, pitted against other methods like Fantasy Talking and OmniHuman. This time, the examples show 2 different people, and we can see sequences of frames that highlight not just the face, but also body posture and hand gestures. This figure gives a clearer picture of how well the model handles more complete human animation, especially when compared to these baselines in challenging and the wild scenarios. Okay, so after seeing those visual comparisons in figures 4, 5, and 6, now gives us some quantitative data from an ablation study. An ablation study is where researchers systematically test different parts of their model to see how each component contributes to the overall performance. Specifically, this table looks at the character image injection module we discussed earlier and compares different ways of integrating the reference image information, which they call token integration strategies. The table shows metrics like VQ for video quality, MD for motion diversity, IP for identity preservation, and LS for lip synchronization. For all these, a higher score is better. And as you can see, the token plus add method, which directly adds the reference image features to the video's internal representation, consistently scores highest across all these measures, confirming it's the most effective approach for this module. So those ablation studies really highlight how carefully they've engineered components like the character image injection module. It's clear HunyuanVideo-Avatar takes a big step forward in creating believable audio-driven human animations, especially for diverse characters and tricky in the wild scenarios. This kind of work is paving the way for more realistic digital humans. Well, that's our show for today. Thanks for joining me, Alex, on the AI Research Roundup.